You are listening to the Gable Media Continuing Education podcast feed, the most entertaining and convenient way for AEC professionals to get continuing education credits, including AIA-approved courses. As a Gable member, just listen and follow the link in the show notes to take a brief quiz and obtain your credit today. Enjoy!
Hi, my name is Carrie Seaburn, professional engineer, and this is Unstruct. Unstruct is the podcast where we share the stories from within your walls to help you understand how they stand today. Welcome back for episode 2. In this episode, we'll talk with Michael Olsen and Peter Kelly with KL&A Engineers and Builders in Denver, Colorado. Our building for today is Meow Wolf, located in Denver, Colorado. And yes, you heard that correctly, Meow Wolf, as in what a cat would say. So Meow Wolf is an art and entertainment company headquartered in Santa Fe, New Mexico, that recently expanded and created a space in Denver, Colorado. So there's a couple of very interesting, peculiar things about this. So Meow Wolf is 5 stories tall, 90,000 square feet, and actually located between 3 major elevated highways in Denver. So if you're familiar with Empower Field at Mile High where the Broncos play, there's I-25 that runs north-south in that area, and then Colfax Avenue that runs west-east, and then it's an on-ramp or an off-ramp right there. But anyway, it creates this loose pie shape, and that's what Meow Wolf used for their construction site. So they loosely filled this shape with essentially a 10-foot offset. So it's super interesting, and as you can imagine, these are major highways, so impeding traffic was not really an option. So they constructed this site and still maintained traffic flow through the area. To describe this a little bit more, it's a little bit like Charlie and the Chocolate Factory. So it's a very whimsical space. The outside is very streamlined, but the inside is very magical, whimsical, complex, almost like the extent of your imagination, I guess. It really is imagination brought to life. There are several art exhibits within this space, and these art exhibits are very elaborate. So some of these art exhibits are multi-storied and actually had to have structural engineering or structural support to hold them up. So they also interrupted the floor plates in some areas. So if you can imagine something that is, multi-storied tall, it has to fit into the space still. So that means that the floor plate had to be removed in some areas to accommodate these multi-storied art exhibits. So the structure is super complex and interesting, but these art exhibits are super complex and interesting and required a lot of structural engineering as well. Another super interesting thing about this is the engineers were told that they needed to make this space flexible for future use. So even though some of these floor plates are missing in some areas and things are very customized for the art exhibits that are currently there, they still had to have future flexibility so that those floor plates could be filled in and so that another tenant could potentially use this space. So I think you're really going to find this discussion interesting. So there's these whimsical, complex parts of this, but then also talking to both Michael and Peter, we get to see the design side and the construction side and kind of how those two fuse together. So today we have Michael Olsen, the detailing manager, and Peter Kelly, the project manager from KL&A. They were the structural engineer of record and also helped out quite a bit with the construction side of things for Meow Wolf in Denver, which is the second building for the entity of Meow Wolf, which is a little difficult to say. So thank you for being here today.
Yeah, thanks for having us.
Yeah, thank you.
Awesome. So maybe if we could start a little bit back way up. So I think this was constructed 2 years ago?
Finished in 2021. Started, I think design, Peter's team was engaged 2017, roughly 2018, early 2018. And then, right kind of through the pandemic, everything. And then it opened fall of 2021.
Okay, so when were you guys contacted about the project?
Yeah, on the design side, like Michael just said, we were brought on pretty early, like late conceptual design, early schematic design, and that was kind of the late fall of 2017. So it was kind of before much of the building had really any definition. It was kind of as it was still very conceptual in nature.
So was this unique site selected at that point?
It was, yeah. The site was selected. The rough vision for the building was selected, but that was about it. There wasn't a lot else in terms of program, even total square footage they were targeting wasn't totally hashed out yet. So all that type of stuff was still kind of on the table and went through the design process, kind of vetting what people wanted out of the project. And it was fun to be able to get to be involved that early on as kind of those level of questions were still being sorted through.
So I noticed that this is a steel frame building. Was that selected early on then? Was that something that was arrived at relatively quickly?
Yeah, it was. When I first got brought on, one of the principals at our office was talking to me about it over lunch, and it was just like, hey, we got this project. It should be pretty cool. It's for this company, Meow Wolf. It's almost a pre-engineered metal building, not quite, but, it'll be this building that has a couple of mezzanines, and it'll be, this art installation. And it wasn't necessarily a discredit to anybody, like our principal included. It just like that's really what the project was conceived of kind of at the time. And that's a kind of testament to how dramatic the design process altered what the building turned out to be in terms of what people wanted out of the project. So it was pretty fun to watch it go through that evolution.
So essentially it was like bits and pieces at a time then as far as the complexity of the project?
Yeah, it was definitely, we knew it was going to be, a unique end use and stuff that would generally require probably some architecturally interesting details and stuff like that. We knew that, but in terms of what those things were or to what extent, continued to shake out all the way through, really until all the art was installed.
Gotcha. So Peter, what was your initial thought when you saw the design first?
It's funny. I mean, the stuff that we just talked about is, it kind of leads to that because I think if I had seen what the end product was going to be, I would have been shocked, but that's not kind of like the vision I saw of the building when I first saw it. So we saw, a unique site and a composite steel building, but other than that, it wasn't anything that really caught your attention off the bat. And then obviously we went to our first design meeting with, the owner was in the room. They had, some of their creative directors there as well. And just get totally blown away by kind of like their vision for what they want the project to be. And so that was kind of when my eyes were opened of like, this is going to be amazing, right? Like this is something different than I thought it was. And so it was like this level of excitement that just kind of ratcheted up as I slowly got introduced to all the players and understood what kind of their goals were and what it was going to mean for the building itself. And obviously a really fun design challenge evolved out of that as well.
So the artwork, is it all their artwork? Like, were they responsible or were there independent companies that were putting art in there that you had to address?
That's a good question. It is all owned by Meow Wolf. They have a lot of in-house production on their side. So a lot of like the anchor spaces, if you're familiar with the building, they have some larger 3-story exhibit spaces. Those are all done and created by the Meow Wolf creative team and artists there. And they also do a great job of doing like local outreach. So there's a lot of local artists in Denver that they contracted with. So they had essentially like white box spaces that were, framed out with chipboard and, MEP and all that type of stuff and given a theme. And so the local artists would then go in and do an installation kind of in that space, kind of hired as a subcontractor for Meow Wolf.
Okay. And Michael, what was your thought when you first saw this? I'm guessing, and you can, I guess, maybe speak to this, but I'm guessing you saw it when it was a little more progressed since you were more on the implementation, the construction side of things?
Right, that's right. Yeah, so I'd heard of this project going through our office on the engineering side called Meow Wolf, and my first reaction was to Google what is Meow Wolf, and you go to their website, you see their original building down in New Mexico, and that's when you get excited about what this project is. You see the art, the crazy lighting, the crazy features of it. So you get excited about what this project could be for the Denver installation. And then when I first saw plans, you're flipping through, you see all these rooms of the spaces, like Peter was saying, for the kind of the white box art spaces. And they have interesting names like Gremlin Symphony Room and Pizza Pal's Room, Ice Castle, The Swamp. So that was kind of my first introduction to it, was looking through architectural plans, seeing all these crazy named rooms and getting excited to get to work.
So this project, like we've talked about, is rather complex and not, I would maybe go as far to say as the opposite of orthogonal. So, and KL&A brought a very unique set of services to the project, right? Because you guys were involved from the design side and then also in the implementation, the construction side of things. So, did you guys use the same software, or how did that relationship work? Was that all through the architect, or Michael, was your part through the contractor, Peter's through the architect? Can you guys just speak to that a little bit?
Yeah, I think from the implementation side, that was maybe a pretty traditional. Peter's using software like Revit, Risa, his analysis programs, doing his design work, and he's still creating construction documents like any other project. And we pick it up from there and recreate in our own steel detailing software. SDS2 is the software we use, and take it from there. We build it from scratch to obviously much higher tolerances, because our software feeds into CNC machinery and material inventory lists, things like that. So different softwares, but the communication was key through all of this. We're talking back and forth all the time, because we got started so early on the construction side that things were still in design evolution as we were going. So lots of communication between Peter and I and both sides of the teams.
As you're speaking, Michael, one thing that I'm thinking of too is like you guys can have a company policy or like a company settings, right? So like those defaults that you have set, it can be the same for both of you, right? As far as like in a model we're using dead load as, self dead load, or adding dead load in there, like just all of those things that sometimes can be a hiccup if you're sharing models with different people. And you guys can do that. That communication piece is already there because you're setting up things with the same default settings. Is that fair to say?
Yeah, our detailing software it includes connection loads. We did some connection design there, but the overall building loads, it's pretty separate. But again, just since we're both on the same team, we're able to communicate and work through some of the bugs that are in traditional processes.
Yeah, I would say one thing that's even more so than the analysis or drawing or detailing models, one of the things that we're able to streamline when we bring those services together is pretty accurate pricing information for the owner and general contractor pretty early on. One of the things that was really cool about this one was that, we used our analysis models early on before we had full drawings ready to go. We would just print off a plan view out of our analysis model that showed beam sizes and stud counts and share that internally with our construction managers. So it allowed, some pretty accurate pricing early on, which really helped, in terms of this project with all the constraints. Obviously, understanding cost up front and as early as possible was an important one. And so having that all in-house and being able to share that level, it didn't have to be polished up to like a full drawing issuance level in order for us to share that internally and get the accurate pricing there, which was a cool integration win, I think, on this project.
That's awesome. So the contractor was involved pretty early on then?
Definitely. Yeah. So to maybe answer one of your questions earlier about kind of the contractual setup there. So the design side, we were contracted as a consultant to the architect, and our construction services are actually detailing included are contracted through the general contractor. So there's kind of a pretty traditional project setup there where the contracts are separate and we're basically just getting to sit next to each other in-house to do those type of things. But contractually, there's a little bit of separation there. It's not necessarily the contractual relationship that was important about the integrated behavior, but the fact that we're able to kind of set some rules for, hey, like we're going to talk about this stuff and sort it out because it's important for the success of the project. Whether that needs to be me just standing up from my desk and going to talk to Michael, or whether that needs to be a formal RFI process through the GC and architect to keep everyone in the loop. There's a lot of flexibility when we're in-house, and we can expedite some things there.
So another piece of this that I don't think we've gotten into too much, but tenant improvements was a huge part of this, I believe, right?
Definitely, yeah.
So I guess for those of the listeners that aren't familiar with kind of the way that structural engineers work, a lot of times we will do a core and shell of the building, which means that we're responsible as engineer of record to have a building that stands up. And what happens on the inside is considered tenant improvements. And a lot of times the tenant is responsible for finding a structural engineer to do these appendages or intermediate interior structures to support whatever they want to make it look nice. But on this project, I think some of these art exhibits are multi-stories tall, and the tenant improvement side was very elaborate, correct?
Yeah, there's this area called the Swamp that is full of these catwalks, and they curve, and there's a cosmohedron in the middle of it, which is a very interesting art piece. But they're so large that you sort of have to build them alongside the core and shell. So that's where early involvement on the construction side really played a key role to be able to figure out sequencing and which of these art exhibits and tenant improvement features needed to be installed and built along with the core and shell. So that was another win for, being integrated and knowing what's coming next after the core and shell.
So did they know kind of what the layout was going to be prior to construction so that they were able to visualize and know what they needed for the tenant improvement side?
So this particular project had a core and shell contract and then a tenant improvement contract, which was basically like the catwalks and stuff like Michael was talking about. Even beyond that, we actually had a scope with Meow Wolf directly that was for engineering of the art installations themselves. Some of them are climbable and other things that the building department wanted to see, stamp calculations for, basically like the design of the art stability. So anyways, on a couple of levels, the first one was, like Michael mentioned earlier, just physically figuring out when the building was going to be too closed up to get some of the large art installations into the building. The catwalks themselves weren't going to, that had to be built in sequence with the primary structure. It was the same, essentially all-in-one structural system, right? Those catwalks are very intimately tied to the primary structure as well. But then also just in terms of defining what pieces of art needed to come in, the owner, they had some pretty sophisticated logistics on their end. They would pack up some shipping containers and just have them craned into the building, like while it was still just a core and shell with some of their, big art pieces in it. So they would drop them off in just a big kind of shipping container, leave them there for a year until the building was done being designed, and then the artist would come unpack them and install them once they were ready to go with that. On the other end of that, too, on the design side, the art was kind of ever evolving, and so like setting some deadlines of like, hey, we're holding, some loading allowances for how much your exhibit might weigh in some of these areas, but there's an amazing amount of things in the installations, and so it adds up quickly in terms of weight. And so there was this consistent like back checking of, as we were doing the art installation design, we would be back checking our core and shell loading against that and expressing to Meow Wolf about, how late in the game those type of things can be reacted to without, big cost implications was a challenge, but also like really rewarding. Like you mentioned earlier, like it was actually really, really amazing to work with the Meow Wolf team, that they are amazingly like logistically complex and sophisticated, and in a lot of ways leading that process. Once we described to them what our constraints were, we were working kind of in lockstep with them the whole way to make sure that we were kind of working on the same problem, understood the loads in the way that we needed to understand them, and understood kind of their end product the way that they wanted us to understand it.
So cool. Like a flash picture in my mind is like when a house is built and they have to kind of put the bathtub, the integral bathtub in the house before the trusses go on. It's like almost the same concept, except for it was a shipping container with a bunch of art pieces that needed to go in before it was buttoned up, which is super fascinating. That's so cool. And I mean, that seems like it took a ton of planning on the ownership side too, to know where they were going to put what. So that's commendable as well. So I want to get into the lateral support of the building, but then I think with this structure, it also brings another question to mind, which is the lateral support of each one of these displays and how to make sure that they are laterally stable for any sort of seismic loads or anything like that. So could you guys maybe speak to, I guess, first the lateral support of the building and then into the lateral support of the exhibits?
The lateral system for the building is cast-in-place concrete shear walls wrapped around a couple of our stairs and one of our elevators. It is a little different than a kind of traditional cast-in-place system in that we used a stay-in-place formwork system. It's called ReadyCore now. I'm not sure if you're familiar with that, but essentially is like a series of steel modules that come out in a core shape. They have the stairs actually already installed inside of them, and they kind of stack up as they go. And you come in and you pour concrete into them once you're ready to go. But one thing about them is they allow you to erect your cores kind of in sequence with the floor system, so you don't have to like pop your cores before you come back in frame steel. They also have stairs inside of them, which is a good benefit for the contractor in that they have kind of OSHA compliant stairs as soon as the cores are lifted into place. So The lateral system was interesting. I mean, the building itself is pretty irregular, including, where the masses and everything live in the building. So some interesting torsional irregularities to solve, as well as the diaphragms are all discontinuous, right? There's these big 3-story exhibit spaces. There's these catwalks framing all over the place. There's a lot of locations where the diaphragms actually don't extend out to the exterior wall, like the art exhibit is up against the exterior wall. So, the lateral system gets pretty complex in terms of these really large 3-story wind columns with wind girts framing into them. The roof itself has a lot of load on it because these wind columns come up and are carrying 3 stories worth of wind load. And so the roof itself actually has some horizontal bracing in the plane of the diaphragm because the shear loads were up there were pretty high. So a lot of really interesting stuff just in terms of allowing kind of all the big openings that needed to happen. That's kind of the crazy part about the diaphragms and the lateral system itself. Once we got to the core walls, nothing too out of the ordinary there, other than the schedule and coordination benefit that we got out of using the ReadyCore system.
Yeah, the ReadyCore, it's a Volcraft product. It's a very innovative system. It's sort of newish to the market, but KL&A has some history with kind of invention of it. It was perfect for this project with site constraints, being able to build right up next to highways, overpasses. But since it was in its sort of infancy, I'll call it, there's a lot of working out bugs with Volcraft, coordinating with them on how they're modeling, detailing, designing their system, and how it interacts with the steel structure itself. So it was cool to work with the ReadyCore team.
What does that look like connecting into it, right, with your steel girders? And then I'm guessing the outside of the core is steel then at that point. Is that correct?
Yeah, it's a metal deck is the outside. They have embeds like a traditional core would, which is what we connect our steel into. Since they're modularized, the embeds have certain size restraints that they have to meet. And then the inside of the core, we detailed the stairs on the inside. And the modules Peter was talking about are, certain heights so that they can ship them, which plays into where if you think of a stair, you can't have a module break right in the middle of a stair. Things have to fit within that core module. So there was some playing around with that.
Did you guys have to do anything special with the, lateral support of these exhibits, like from a seismic perspective?
Yeah, definitely. So some of the exhibits are more of the flavor of something hanging from the ceiling. Michael, I think, mentioned the Gremlin Symphony earlier. That's basically this room where there's a bunch of musical instruments hanging on the walls and ceiling, and there's essentially a grid of steel that hangs all of that musical equipment. And so that, is using like non-structural components, loading from ASC7 on checking the bracing of that kind of racking system. And then, there's other components like you mentioned the cosmohedron earlier, which is this 3-story. It's basically a building inside the building. I don't know how to describe it other than, it doesn't look like a building when you approach it. It's clad with colored polycarbonate panels and stuff like that. But it looks kind of like a swamp animal. But it's 3 stories tall, and, people can go, there's floor levels in there. People can go and walk around. And so, that one is designed with story forces, just like you would design a typical building and looking at lateral loads there. And it frames into these catwalks at each of the levels in the swamp. And so, looking at how that lateral system from the cosmohedron interacts with the main building system, there's actually some little isolation joints at the catwalks to keep them moving a little separately so that we don't accidentally load up the catwalk in a way that we weren't planning on. So yeah, all across the board, but yeah, pretty detailed design on a lot of the exhibit stuff, anything that someone could climb or get into in some form or fashion, which is really, a lot of the art is intended that way, to be experienced by people climbing on it and getting into it and stuff. The jurisdiction generally wanted to see full calculations on those, both gravity and lateral design.
Well, and as you're talking, that makes so much sense that the engineer of record would be responsible for that instead of, a more traditional, probably simpler, it'd probably be a simpler building. But if there's multiple tenants and then each tenant is hiring someone separately to do their support, then it doesn't look cohesive throughout. Whereas if you're doing all of it, where you're putting loads or where you're not putting loads on the structure. So it takes out that coordination piece of it as well.
Yeah, definitely. I think there's a decent amount of coordination up front to try to understand where the heavy point loads were going to come. And so you would put, a piece of steel below our composite deck if we knew there was going to be a very large point load. But, a lot of coordination on the back end too, as we discovered, exactly where heavy things were going to be. I'd be on the phone with Michael trying to figure out how do we define the work points of this irregular thing and where we're going to have a load and give ourselves flexibility for if, this thing's going to maybe want to be moved 6 inches one way or another. Does that totally kill our detail in terms of how we wanted the load to flow and all that type of stuff? Yeah, it was, I would say, critical for us to be involved on that level as the engineer of record on those type of decisions. Obviously, you could do it as a deferred submittal or have a third-party engineer, but the amount of information flowing back and forth to make sure that would all be covered would be a challenge for sure.
Yeah, lots of RFIs too, I'm sure.
Yeah, I think so. For this project, it's very geometry intensive, loading intensive. Reactions were interesting. Total for the project, there was maybe less than a dozen RFIs, and these weren't like RFIs from us as detailers to Peter as engineer. It was questions to the architect about finishes or rail systems or whatever. So that speaks to our being able to work side by side as engineers, detailers, to build the building in a virtual world from drawings that Peter's team was creating. So yeah, less than a dozen RFIs on a building like this in a traditional kind of format, contractual setup, probably have dozens and dozens of RFIs just to get through the steel structure.
That's unheard of. That's amazing, you guys. Like, I feel like, yeah, like in the old school days, there'd be like when we used to print things off, there'd be like binders and binders of RFIs or something like this. Okay, so a little question, like moving over to the gravity side of things, and this might be more for you, Michael, but I know you guys had some mechanical things to contend with, right? And working it into structure so that it wasn't recessed down from the underside of the structure so that there wasn't any sort of drop soffit situations. Can you speak to that a little bit, Michael, as to the coordination with mechanical?
Yeah, beam penetrations. That's a fun topic on this project. But yeah, of course, the first sequence of steel, it's Murphy's Law or whatever, that always has the most beam penetrations in it. And of course, they're not coordinated when we get started. So as we're working through this, we see all these beam penetrations that are needed, but we're hearing from our engineering team that, hey, maybe mechanical's not, they're still tweaking things, they're not quite done. We're trying to push forward with creating shop drawings and getting stuff fabricated. And our engineers are saying, hold on, we're still tweaking. I think Peter had to work through, multiple rounds of beam penetrations, but the win on that is that on our side, we didn't have to do multiple rounds of beam penetration coordination because we knew from hearing that things were still in the works. We were able to hold off, work on the right thing at the right time, send stuff for review or fabrication, the right thing at the right time, so that there wasn't beam penetrations that were sent to the shop that had to be fixed or moved or added. So there was a lot of work in there, but having engineers, detailers working side by side, that was a win just to know how to work the mechanical system.
So, Michael, how did you get shop drawings to Peter and then also to the steel erector? What was that deliverable?
So pretty traditional process. Again, we were creating shop drawings. We'd have a review process. But ahead of the review process, Peter and I would sit in front of the steel detailing model and spin through the model, look at things, understand geometry in a 3D environment, a virtual environment, before we, went through the work of creating the shop drawings and doing the whole submittal. We kind of pre-vetted things. We were on the phone constantly trying to figure out connections as we were modeling them. Something with a 200 kip reaction with a non-orthogonal connection. We were spin around that and say, okay, how many bolts could we fit in here? What size plates can we fit in here? What does this look like? Let's design the geometry alongside the analysis, kind of work them hand in hand, which maybe a traditional process would be to sort of analyze. As a detailer, I know that engineers aren't always seeing the full geometry, everything that's constraining that connection. But with Peter and I, we were able to look at the model together, sit side by side, and figure out geometry and roll from there. And then beyond that, we went to the traditional process of, review drawings, go to the GC, the architect, and back. But a lot of the red lines were minimized because we were able to vet everything out.
A lot of the stuff that you might normally see like on a shop drawing as a structural engineer from the detailer about, like, please confirm this condition. These number of bolts don't match your typical detail for XYZ reason. A lot of that stuff we were able to vet through ahead of time. And so for the structural team, it was, mostly validation when we got the final PDF version for review. But obviously still with the contractual relationships, needing to keep the architect and GC and other subcontractors in the loop through kind of formal project documentation was an important piece of that as well.
That's so cool. I feel like even just like a 4-hour or, even a 2-hour sit down with both of you guys looking through things could save 8 hours or, I think it saves so much more time in that back and forth. And it takes a lot as a detailer to make those comments and to think what they are and then to respond as the engineer of record as well. But if you can just sit there and be in the same space and look at the same model, that's huge. I think that's awesome.
Going back to RFIs too, the amount of time that it takes for us to generate an RFI, engineers to answer that, come back, probably isn't the right answer, or there's something else that they're not seeing. Just the time saving, I think you hit on, it was huge, being able to work side by side with engineers, steel detailers.
So, Michael, how were you able to convey those complex details and the complex geometry to the steel erector?
Yeah, both the erector and the fabricator, right? Because they're both building it in different facets. The fabricator, I'll start there because they're the first ones to see shop drawings. They were a new partner to us, the HME out in Topeka, Kansas. There was a little bit of risk there being a new partner, but they were great. They're very tech savvy. They have a lot of automation in their shop. So our detailing model, creating it as accurate as possible, really fed into their CNC machinery to allow them to automate as much as they can through their shop, which was key. And then the erector was LPR Construction, which is a Colorado company who we've worked with on many, many projects. And again, another very trusted partner that we're close with, and we were able to sit down with and spin through models and show them, hey, here's some tricky spots, and how do you want this sequence, and what's a good connection for you to make in the field versus some other ideas. So again, just having really good partners and teammates that had a kind of an integrated or an outward mindset to be able to build this project was very key for this project. It was great.
Speaks volumes just with the number of RFIs that you're saying. Like, that means everyone was able to communicate very well and get things conveyed in the way that they needed to be. So switching gears a little bit, what were some of the challenges that came up with the site constraints?
As you described, this building sits within 3 major highways within Denver, and they're all over, elevated highways. And there were roads that could not be shut down under any circumstances. So they were elevated, so we were able to pull stuff underneath the highways in order to erect it. That was a key point of discussion about where the crane would be. The crane ended up being within the elevator core in the center of the building. And, materials and these art exhibits and shipping containers were all trucked underneath the highways and then brought up through the building. So it led to some very unique sequencing challenges because you had to leave open spaces in the building to bring materials up through. Usually you want the crane on the outside of the building so that you can swing across it, but we couldn't do that in this instance. So definitely some challenges with cranes and shipping logistics, things like that.
I was going to ask you, I'm glad you spoke to this. I was going to ask you if any of those highways had to be shut down for construction.
It was one night, I think, when the off-ramp was closed in order to, I think it was just the mobilization and demobilization of the crane itself. They had to have an assist crane come in to pull it off. So
crazy. That's huge. Like, that's amazing. How close does the building structure get to the highways?
It's 10 feet all the way around. That was kind of like the setback. So it follows the curve of the road pretty precisely. If you look at a satellite image of it, it's formed to fit the 10-foot offset all the way around.
Crazy. So the crane operator was pretty much like a surgeon then.
Yeah, that's a good term. Precise. If you're driving on the highway and you stop at the stoplight and your window's down, you feel like you can almost reach out your window and touch the building. It's just right there. Super close.
It's so cool. That's awesome. What is the most fascinating thing or the most the thing that you found the most fascinating about the design of this building?
So for me, we've mentioned a couple times the cosmohedron, which Peter tried to describe. It's sort of a 3-story building within the building, and that's this weird shape. It's almost like a snowman, but there's this stair that wraps around the side of the cosmohedron to get up to the second level of this, and that stair is the most unique stair I've ever seen. It's, first of all, it's a spiral stair, which is unique in of itself, but each tread is unique, different lengths. The guardrail is a vertical plate that kind of curves at the tip. It sort of looks like a snowboard. We call them the snowboard plates. So each one of those are unique as it goes around. That stair and that cosmohedron was a challenge, but it was a fun challenge. We got to work with the artists on that one, architects, engineers. The whole team really came together on that one. I'll give a shout out to Tim Fuller of my team that built that stair. He put a lot of time into that stair, and it turned out really, really cool.
Yeah, I totally agree. The cosmohedron's pretty sweet. Man, it's tough to pick one, I think, from my side. One thing that's interesting about the building is that we talked a little bit about loads earlier in terms of art exhibits. There was actually a second parallel design that ran all the way through construction documents, permit level documents, where the owner wanted the ability to potentially repurpose the building. If for some reason Meow Wolf didn't occupy the building or didn't use it as planned, that they wanted the ability to basically turn it into anything they wanted to. So what that meant was they told us to design for a storage loading case. So a scenario where all the floors were like fully infilled, so all the crazy openings for the art exhibit would be infilled with floor framing. And then we were designing for, a storage, quote unquote storage case, which basically was just a large load allowance so that it could be, flexible to be whatever in the future. So it's pretty interesting in terms of this building has baked into it this kind of other DNA of, it's a pretty long span composite steel framed building, as you would expect from a, museum type structure. But then it has these pretty crazy load demands on it from the secondary design that's in place. So kind of a cool backstory on the back end. And, in a lot of cases, you would think storage loading, that's crazy. That's going to be really heavy. But to be honest, the art exhibits controlled a lot of the loading anyways. So it was interesting comparison, but just kind of the bookkeeping and the fact that there is this kind of secondary potential use for the building was a cool story on the design side.
That's so fascinating. So like you were talking earlier about the diaphragms having, being cut up, having lots of discontinuities. But then at the end of the day, you're not only designing for that, because that's the final condition, but then this alternate final condition of like everything being infilled again with the super high load.
Yeah, exactly. So the lateral system is designed for each case, right? That's really the one where the lateral loads are quite a bit different. Obviously, if you infill the whole building, you got quite a bit more mass. But other than that, yeah, it was really interesting. Like you said, a lot of the elements, it's not immediately obvious which one of those scenarios is going to control for each individual element or connection or anything like that. So all of that bookkeeping process is it was really fascinating.
That is so cool. So if you could give this building a theme song, a question that you've probably never been asked before, but if you could give the building a theme song, what would it be?
For this building, you go a lot of different ways with that. There's a lot of interesting songs out there, but one that came to mind for me was Bohemian Rhapsody by Queen. It starts off, "Is this the real life? Is this just fantasy? Caught in a landslide, no escape from reality." I won't sing it, but that's a weird song, and it probably fits this building.
Yes, that's awesome. And it has a bunch of different lives throughout the song, right? It's slow and then it's fast.
Yeah, exactly. Yeah.
Yeah, it's what it feels like to walk through the exhibit spaces for sure.
Yes, awesome. Peter, do you have a different song, or would you?
Yeah, I'll concur with Michael on that one. It's funny. It was like, man, I don't know if I'm with all the creative people that were on this project. I feel underqualified to assign it like a song to box it in like that. But I think I agree with Michael, so I think I'll go with that.
That's awesome. Okay, and then the last question for you guys, because I ask everyone this, and I may have a vested interest in this, but are you left-handed or right-handed?
Right-handed.
I'm right-handed also.
Okay. Now I'm up to about 50-50, I think. So I have a theory where I feel like a lot of engineers, a lot of my friends are left-handed. I'm left-handed, which is why I had the question. But now it's up to 50-50. So I think you guys might be helping to expose this myth that I have in my own head.
That's interesting. 50-50, I would have thought, is a pretty high ratio.
Yeah, exactly. You got a large proportion of left-handers there.
Yeah, I guess, right? Compared to the general public. Yes. So, I mean, I was hoping for like 80-20, but that's okay. Anyway, that is all I have. So Peter and Michael, thank you so much for being here. Meow Wolf is amazing. You guys did amazing structural design work. I hope you're super proud of the building and everything else that you're doing. And thanks so much for being here today.
Yeah, thanks for having us.
Yeah, thanks for letting us reminisce and talk about it. It was a fun project.
Thank you for listening. If you enjoyed this episode of Unstruct and know someone else who would, please share it with them. And if you enjoy the work that I'm doing here in general, I would really appreciate your rating and review on Apple Podcast. It goes a long way to help others find the show. Speaking of finding shows, Unstruct is part of the Gable Media Network, a place where you can find even more content like this. To see the catalog of shows focused on our built environment, visit gablemedia.com. That's GABL media.com. Lastly, if you haven't already, don't forget to subscribe before you go so that you don't miss the next story from within the walls and how they stand today.
No, I'm not a writer.
Okay.